So in lesson 5.1, we're going to learn how to deal with exponents that are integers. So up to this point, we've only been focusing on exponents that are whole numbers, like starting at 1 and 2 and 3 and 4. We're going to talk about how we work with exponents when they are either equal to 0 or equal to -1. So we want to be able to simplify numerical expressions and algebraic expressions that have integer exponents. We want to be able to apply other rules of exponents that we've learned about previously, like multiplying and dividing, but now we'll have those negative exponents and zero exponents. And we want to be able to simplify sums and differences of expressions that have integer exponents. So like I said, up to this point, we've only used positive integers as our exponents. And we know that when we see something like an expression b to the n power, that n has up to this point always been a positive integer. And what it represents is repeated multiplication. So if you have b to the n power, that means you're multiplying b by itself over and over and over again, n times. So what about when we have an exponent of 0? Well, let's apply that addition rule, or let's apply one of the rules that we've learned about previously to understand why, when we raise something to the 0 power, it's equal to 1. So we know, for instance, that when we multiply two like bases together, we can add their exponents to get the final exponent in our answer. So if we, for instance, had x to the 4th times x to the 0, then that would be x to the 4 plus 0, which is x to the 4. Well, notice you must have multiplied x to the 4 by 1 to get x to the 4. So x to the 0 power has to be equal to 1. Anything to the 0 power is always equal to 1. So this is another rule for exponents that we're going to add to our toolbox. Any number, any expression raised to the 0 power will always equal 1. The next rule for exponents is those for negative exponents. So let's consider this problem where we have x to the 4th times x to the -4th. Once again, we know to add those exponents, so we would get x to the 4 plus -4, which equals x to the 0. And we've said anything to the 0 power is always equal to 1. So what does that say about x to the -4? Well, when you multiply two expressions together and the product that you get is 1, then those two expressions must be reciprocals of one another. So x to the -4 must be the reciprocal of x to the +4 if you get a product of 1 when multiplying them. So what does that mean about negative exponents? It means that when you see a negative exponent in an expression, you can just flip the base. If that x to the -4, if you want to change that -4 exponent to a positive, you can just flip the base of x and write it, instead of as x over 1, which is what it really is here, write it as 1 over x. And now it will be to the +4 power. So this tells us that any expression raised to a negative number will always be equal to the reciprocal of that base, b, which would be 1 over b, raised to the +n power. So let's try it with just a couple of these simple ones, and then the videos that follow will go into greater depth on some of the trickier expressions that need to be simplified, that have 0 exponents and negative exponents. So if you see x to the -5, that negative exponent you've got to immediately recognize needs to be changed to a positive exponent by flipping the x. It's currently x over 1. It will become 1 over x. That is the reciprocal. And then it will be to the +5 power. You can do it with numbers as well. To make that -4 exponent a +4 exponent, you flip the base of 2. The reciprocal of 2 is 1/2. So that becomes 1/2 to the +4 power, which is 1 over 2 times 2 times 2 times 2, which is 1/16. Or 10 to the -2, that becomes 1 over 10 to the +2. And 10 squared is 100, so 1 over 100 is the same as 0.01. Now here, there's a simpler way to do it than I've demonstrated here on this slide. Notice the 2 on top does not have a negative exponent, but the x on bottom does. Well, a real nice trick to use when we're flipping the base to get a positive exponent is just to take any base that has a negative exponent and move it to the other location in the fraction. When I say other location, in this case, the x to the -3 is on the bottom. So to flip it, you can just move the x to the top, and then the exponent becomes a +3. You can skip this middle step, which can be confusing for some of us. 2 divided by 1 over x to the third is the same as 2 times the reciprocal of that. So that just ends up being 2x cubed. Notice we did nothing with the 2. It stayed put because it didn't have a negative exponent. Here, we have an entire fraction as our base with a negative exponent. So we flip that entire fraction. We can skip these 2 middle steps. If you flip 3/4, you get 4/3. And now that's to the +2 power. So that means the 4 gets squared on top to get 16, and the 3 gets squared on bottom to get 9. So if we recap all of the different properties of exponents that we now have, I've got them all summarized here on the next slide. We've got this one that says when you divide like bases, you subtract their exponents. We're going to continue to use that. We have the new one that says anything to the 0 power is 1, and anything to a negative power is the reciprocal of that base to a positive power. But then we also have this rule that reminds us that when you multiply like bases, you add their exponents. When you have one base with 2 exponents, you multiply those exponents. When you have a quantity raised to an exponent, you distribute that exponent. When that quantity is multiplication, then you end up with a to the n times b to the n. When it's division, you end up with a to the n divided by b to the n. And here's that last one that says that when you divide like bases, you subtract their exponents. So in the videos that follow this one, we're going to be incorporating not only the new rules for exponents, 0 exponents and negative exponents, but we'll also see that we'll be using the previous rules that we learned about at the beginning of Chapter 3.